And for our last speaker of the day, we have Nihil Babu. Nihil is a senior, I'm so sorry, is a senior manager in cloud native engineering at Adfolks. He is interested in building all things distribute and developing highly scalable and secure cloud native infrastructures. Today, his topic is on AWS advanced networking using traffic gateways and WAN. Please help me in welcoming Nihil Babu.
Yeah, thank you. Yeah. So, hi guys. So today we will be mostly looking into network side of AWS, where how an organization transit from an SMB to an enterprise level. So recently, I'm actually not from a network background. I started as a developer, then moved into cloud native plus infrastructure side of things, mostly DevOps and cloud native side. Last couple of years, I was mostly focused on network side as well, because what we found is from Adfolks side, mostly my team handles greenfield deployments, so that's fresh environments, where after a particular point of time, we understood that once we deploy the applications or once customer onboarded or the customers are coming into the environment, there are a lot of issues happening from a network side. That can be an integration, that can be external security side, as well as other things also. And one thing also we found basically is once your network is not well optimized, you are paying a lot. The customers which we work has mostly semi-government plus those kind of entity which has a lot of integrations, as well as they have their own data centers plus other connectivity, where we found that their billing has been increased a lot due to the traffic charges, as well as there are a couple of other small issues like packet drops, which are affecting the application, which is very hard to debug. Then we had to step into the network side of things, where we were going back into networking and just checking out all the different architectures, as well as how a customer is transitioning from one architecture to the other architecture. Okay, why network matters on a cloud-based system? Because end of the day, everyone knows that in cloud, from a network side of things, you don't need to handle much of the things, because when it comes to data center, you need to handle your routing, switching, and all other stuff. In cloud, all these are abstracted. Okay, but a well-architected cloud environment can be easily scalable, can be easily integrated with other networks as well as other environments. Then when it comes to the performance side also, we have noticed significantly that if you are choosing a wrong architecture, there are traffic which is going into the places where it doesn't make sense. And basically from an application side of things, nothing breaks, but you are having increase in latency, things like that. The other big aspect is scalability. So when your business grows, your network also need to grow from one environment to the other environments. The customers which I'm talking about is mostly B2B customers, as well as some of the B2C customers. What we found is, like, from a B2C perspective, the network should be very simple, because from a B2C, your customers are coming from outside. There is not much integrations. Let's take an example of an e-commerce where you have your entire cloud environment running on AWS, where the customers are coming from outside. The only integrations which you might have will be to your warehouse or some analytics things, that's it. But when it comes to B2B integrations, you have many different offices. Corporate office which sits on multiple regions as well as multiple cloud environments. Couple of the organizations take stand that they need a multi-cloud strategy as well. So all these need to be integrated seamlessly. There will be an application running on your data center which sits on US, but that need an integration to an application which is running on AWS in India. So how that traffic need to be handled securely. Then basically you have the security side of things, where you will bring in different type of appliance for different purposes. Once you pass a point where you will have multiple security solutions in place. So one of the recent ones which we are seeing, basically customers are using multi-vendor firewalls. So basically they will have like at least 2 different firewalls from 2 different vendors. The main objective for that is basically vendor bugs. So if any particular product has any vulnerability, the other appliance should catch it. Then depends on use cases where you are placing your security devices. We have seen dedicated firewalls for different purpose. Basically, there will be one firewall which does the L7 inspection, so that's your web inspection. A dedicated firewall for L4. Then you have some WAN optimizer coming into the picture where you are using a firewall for your on-prem connectivity. All 3 will be 3 different solutions. Then basically cost, you can save a lot because once you do integrations to your on-prem or multiple cloud, there are traffic which is leaving your cloud. So in cloud, what we always know is like basically ingress cost is free, but egress you need to pay. So how to optimize on those kind of things? Then basic things, reliability and flexibility on, like let's say if you want to bypass certain security rules, how you can do it very quicker. Okay. So now comes to the evolution of network architecture for an organization. Okay. So this is stage one, where you are a small business, where you are having a single VPC, which will be a 3-tier application. Mostly that's enough. Because you are just starting your business, there is no point on investing heavy on infrastructure, heavy on application. So usually what we see from a startup side, what we also recommend for smaller customers is basically start with something very similar, very small, like a monolith app, it's fine. Once your customers are onboarded, once you're getting business, then only scale out. The second stage, which is a stage where the most of the customers spend bulk of their time. So from a percentage-wise, stage one, customer will spend only 5% of their time on stage one. Stage two is a bigger stage where you are spending around 60% of your timeline there, where you are moving to a hub and spoke model. In hub and spoke model, basically you will have a hub network, then there are all other spoke network. So hub network is something which will stand in between your trusted network as well as your untrusted network, basically your internet. So any traffic which is coming in and going out to internet will pass through this hub. Spokes are the VPCs where your applications has been hosted. Okay. Then when it comes to transit gateways, one thing about AWS network was it has evolved a lot by introducing transit gateways as well as the WAN, where it made the connectivity so much simpler. Hub and spoke model works really good. It scales really better. But there are a couple of shortcomings when it comes to hub and spoke architecture, where if you want traffic to go in a certain way, that is, in sometimes hub and spoke is very rigid on that one. And when it comes to transit gateway, those things has been very simplified, as well as the connectivity. Hub and spoke is really good if most of your environments are in cloud and in a single region. So if you are going to a secondary region, then you need to have a new hub there, then you need to have a spoke there. But when it comes to an external connectivity, like your direct connect or a VPN gateway, hub and spoke model doesn't scale that much because you have an end of limitation on your hub side, which is end of the day, it's a VPC. So that's where transit gateway comes in, which scales really good to a point there you can avoid certain things. Okay. Then connectivity between inter-region is very simple because basically you can have a transit gateway on different regions where you will put each transit gateway, then those transit gateway can talk to each other. Okay. Then comes to the stage 4. Stage 4 is something not, I would say new in AWS, which is something called Cloud WAN. It evolves a lot in last couple of years, where right now it become a good product because end of the day, when you are a big business, you need to have a WAN. Basically, WAN is your corporate network, which scales globally, where you have, if there's some data centers are in your US or India somewhere, plus you have multiple regions, you will have a cloud WAN. Previously, customers are used to having their own WAN devices. So basically, they will create their own cloud WAN using multiple devices like Cisco, Meraki, or products like that, where they are managing their own WAN. What AWS has done is basically they have introduced a WAN service, so we don't need to manage the devices. Basically, you can deploy a WAN, you can get started running in within a couple of clicks, as well as in a couple of hours, a full-fledged WAN can be deployed and managed. Okay. Now, when it comes to a small business setup, as we discussed, it's a typical architecture for an entry-level one. So this is basically an architecture what we do for like even for learning purpose. Basically, you will have your 3-level architecture where you have your internet gateway as well as the NAT gateway for the traffic. It's a simple setup. It can scale a lot. When I say small business, it means sometimes it doesn't mean like your business need to be very small. We have seen customers using this particular architecture for scaling really good. For example, for that one, this was an architecture which looks very simple. This we have deployed on 2020 for a customer, which is not an e-commerce customer, like it's kind of an e-commerce. Let's say if you want an e-commerce, you can go to them. They will host your e-commerce. This particular architecture scales really good. One thing we noticed was like for this particular environment, we are receiving around 78K requests per second. So that's a highly scalable environment, and they had highly throughput. Even in nights also, they were getting around like 50K requests per second. So it scales really good. And for this customer, why we choose this environment instead of doing multiple things, it's a B2C end of the day. You have all your security, L7 security handled by Cloudflare. Then you have your application load balancers, things like that. They don't need much integrations because end of the day, they didn't had any on-prem systems where they need to communicate. So this works really good. The application was hosted on EKS, then they have all the databases here. Okay. Now when it comes to a hub-spoke architecture, so how a hub-spoke architecture works is basically you have something called a hub, then you have all your spokes on. So hub is a place where it stands between your outside network as well as your inside network, where you are terminating all your traffic to a hub. Okay, that means for an application which is running on VPC-A, if an end user want to communicate to the application VPC-A, it need to go through the hub network. Okay, and vice versa. If an application has an integration from VPC-A to VPC-C, that traffic will go through the hub model. Okay, and prime example for a hub-spoke architecture is basically we are doing a centralized ingress. So all the traffic which is coming to your environment will need to go through that hub environment where you are doing your basic application load balancer plus your firewall inspection, things like that. This works really good. Let's say as a corporate organization, if you have 10 or 20 applications, you don't need to have a separate ALB or separate firewalls for doing security. You are centralizing all these things, which can bring down the cost, as well as it can do a centralized governance. So from an organization-wide, let's say if I am changing something on my WAF, that is already applied to all my application which is there. So in this one, how the basic routing happens. So basically, this we are focusing on the ingress side of things. Basically, all your layer 7 appliances will be on your hub side. Then when it goes to the spoke side, it will go through a firewall. That is not mandatory. You can bypass that. The reason why we put a firewall there too is just basically to manage the L4 security. Then any traffic which is going to spoke, that will also go through the hub side. There is a couple of issues with this architecture where basically you are limited to the CIDR range on your VPC hub. So let's say if you have some VPN gateways or direct connect which is coming to the picture, which will eat into your particular CIDR range from an hub side, that's where your mostly the limitation comes. Okay. Then if you want to integrate with the other regions, you are peering your hub VPCs between each other. That becomes a really big nightmare because once you have multiple hubs connected to each other, routing the traffic between these things become a headache. Then all other things, BGP and eBGP things come into the picture where it's really hard to debug once something goes wrong. Okay. Now, from an implementation side, if you take an centralized egress way, so if an application from your spokes need to communicate something into internet, how that traffic will happen. So you have your internet gateway as well as transit gateways, everything. NAT gateways, everything will be deployed on hub. In your spoke environments, there's nothing. Those can be a private subnets. Then if you want to route something which is specific to internet, what you will do is like you will basically route everything 0.0 to the firewall interface actually. So from there, it will go out, it will come in. So basically, you can do a centralized ingress and egress using hub, where you have all your control on the network side. Okay. Okay, we'll skip it. So now comes AWS Transit Gateway. Basically, a transit gateway is something which can help you to connect multiple networks or multiple VPCs together. Okay. Before we use VPC peering for peering all the networks together, which theoretically there is no performance degradation or performance penalty there. But once you are in a hub and spoke model, sometimes if you want to skip traffic for debugging purpose, that becomes really painful because you cannot do that. Because at the end of the day, once you push all your routes and everything, the environment is pretty much static. You are controlling everything using static routing. What transit gateways allow us to do is basically it's kind of a hub-spoke model, but you have some more control on top of it, where you don't need to give your CIDR range. basically when you deploy a hub, you need to give your own VPC. Transit gateway is an object where you can connect all your VPCs together. It can also connect between your site-to-site VPN as well as the direct connect. So those are native objects to the transit gateway. Okay. Then transit gateway has other feature where it can connect to a transit gateway in the same region or in another region. This comes really handy basically when as an organization, what we also notice from our couple of customers is basically they will start, once they start growing their business, instead of growing their own team, they start acquiring people. Okay, so they start acquiring companies which does the similar thing in another region. They will ask them to integrate everything together. Where transit gateways was really good, because what we will do is like for the particular organization, if they are using transit gateway, we'll ask them to attach their transit gateway with our transit gateway. Or else if they are only using some VPCs, we'll ask them to directly connect to a transit gateway and give us the connection to the transit gateway. Same for the direct connect as well as the site-to-site VPN one. Okay, so let's take an example of how the routing works. Basically, for each connectivity to a transit gateway, we have something called an attachments. Okay, so when you attach something to a transit gateway, there is an attachment. So that attachment has its own routing happening. So let's take an example of from an AWS region, you are sending a packet which has a source IP of 10.128.0.224. Okay, so that is the source. That means this region. Okay, the IP over here is actually wrong. Sorry about that. It need to go to the VPC, prod VPC, which is 10.0.0.9. So once this particular packet comes to the transit gateway, there is a route table associated with your transit gateway. Okay, so you have route tables, which is your native VPC route tables, where you are saying that, okay, if traffic to 10 range, 10.0 range or 10.1 or 10.2, you will say in your VPC, if the traffic to those environments comes, send to the transit gateway. Okay, once that traffic reaches your transit gateway, then you will have an route table says that, okay, if you are seeing that particular traffic, then send to attachment A. Like that. Okay, so there are two types of routing need to be happen. One is from a VPC layer, where you are saying that all the traffic to other VPCs or other network need to go to transit gateway. Then you will come into the transit gateway and say that, okay, if you are getting a traffic for this particular IP range, send to that particular attachment. Okay, that's how it will match it. So once the route is matched, then it will go to that particular one. Same for the return route. Return route also, you need to have your own route tables attached to the transit gateway. Okay, so this is a scenario where you are connecting. Basically, you have a transit gateway sits on region A, then you have a transit gateway sits on region B. You are connecting transit gateway two together. Then you have to write the rule which we discussed. Okay. Then one more thing, when it comes to hub and spoke, the main advantage was we can inspect the traffic, you can do security. When it comes to transit gateway, you can do the same thing. Here routings are much more cleaner. Sometimes you will face into issues, but you can do a bypassing as well. Because in case of hub and spoke model, all the traffic need to come to the hub, then only you can actually send to the different application or the spokes. But in case of transit gateway, as we know, or the route table which we have seen here, you can actually do a bypass rule. So basically, sometimes for debugging, you will say that, okay, instead of sending to the firewall, send directly to your other VPC. Okay, so that's where what we are doing right now here. So in case of AWS, mostly, and they don't call it as a hub environment, they mostly call it as an inspect VPC where your firewalls and everything is sitting. So basically, if you want to send traffic to your particular inspect VPC, what you will do is like, you will say that, okay, if traffic from VPC 2 to VPC 1, that need to go to transit gateway. Then in transit gateway, you will write a rule that, okay, any traffic coming to the transit gateway, send it to the inspect VPC. Okay. Once that reaches the inspect VPC, then you can do all your inspection security like that one. Then it will come back to the transit gateway where you are routing to the VPC 1. Okay. In this case, you can do really good bypassing. Basically, you can just put a rule in the transit gateway route table says that, okay, from VPC 1 to VPC 2, any traffic going, don't send it to like inspect VPC, directly send it to VPC 2. Mostly it's required. Basically, if you take an example, if you're a development house, you have different networks like your dev, shared, things like that, where if you have multiple dev and where dev VPCs, you don't want them to go to the firewall. Okay, basically it's an untrusted network, and it can be an untrusted network. You don't need to do an inspection there because we know that, like, okay, developers are doing something ad hoc. We don't want to block them. So during those scenarios, what you can do is, like, if it's a dev environment, you will say that, okay, dev VPC to dev VPC, directly send it. But this becomes unmanageable very quickly, because then you have a scenario where you are sending a couple of the traffic to firewalls, or you are inspect VPC, some of them directly. So when a new team comes into the picture, or when you are scaling exponentially, this will become unmanageable. So when the teams are adopting this particular architecture, what they do is, like, they will send everything to the firewall. Then they have different firewalls for different purpose. That's where WAN comes into the picture. WAN is really good at that stuff. So in case of WAN, how a WAN looks like is basically WAN has a network which can spread across multiple regions. Then what you will do is, like, you will create a different segments. So you can have a development segment, a production segment, as well as a shared segment, where you are saying that it's basically tagging. So when I create a VPC or something, I can tag it as, okay, this is actually part of a development segment. So once you have all these segments, then what you can do is, like, you can simply write a policy says that, okay, traffic inside the dev segment is, we don't need to inspect. It's a direct communication. Anything going between development and shared, that need to be inspected. Anything coming into the production, that need to be inspected. Then you can write some more rules which AWS has introduced last 1 year. Basically, in production segment itself, if you have multiple VPC, you can write a rule saying that, okay, from within production segment, if any traffic is going to VPC, even in production VPC, you can actually do an inspection. So all these WAN things are managed by policies. Okay, those policies can be automated using CloudFormation template, as well as, like, normal Terraform scripts. Okay, and if you want, you can have your SD-WAN connectivity, things like that, which will be coming into your Cloud WAN. Okay, so there is actually no demo for the particular one, because we just gone through all, not all, basically the high-level architectures on how an organization adopt network, basically. Okay. If you have any questions, we can discuss. Yeah.
Any questions? No? Then I would like to invite Tinsy over to hand over the speaker gift as a token of our appreciation.
Yeah. Thank you.
A round of applause, please, everyone.
Yeah.
Thank you so much.
Yeah. Yeah. Thank you.